Hi there, it's Mrs. Vernon here to talk to you today about solving systems of equations. Today we're going to talk about solving by graphing as well as doing some basic solving with substitution. Let's take a look at the warm-up. What I'd like you to do is I'd like you to pause the video, following along with your notes guide. I'd like you to try the warm-up first before you actually watch my explanation of it. So go ahead, pause the video, give it a try, and when you're ready to check your work, go ahead and hit play again. I hope your efforts were well paid off and you got the correct answer. Let's go ahead and take a look at the answers. So whenever you're looking at this information, you're going to want to make sure that you focus on the slope of the line and the y-intercept. Now the y-intercept is going to tell us where to start our graph at. In this case, our graph should start at positive 4. So I'm going to go ahead to the 4 on the y-axis and put a dot. And then my slope is telling me to go down 1 and to the right 2. Notice that my slope is running downhill. It is a negative slope, and so it is running downhill. Once I get some dots plotted, I can connect those dots. Oops, 1 second here. I have the wrong line up there. I can connect those dots with a straight line, not a curved line. So when we go ahead and put in that straight line, we'll see this graph here. Next, we have to graph the next line. When I go to graph that line, we're going to want to make sure that we also, again, pay attention to the slope and y-intercept. Our y-intercept here is -3. So I'm going to start at -3 on the y-axis. And then my slope is -4, which says I can go down 4 units and to the right 1. Now that feels like I'm kind of hitting a dead end. 2, 3, 4. So I can also go up 4 units, and then I'm going to go to the left though. Again, I want to make sure that my line is running downhill. Now as I go ahead and look at these points that I'm getting, I am quickly recognizing that my solution is very easily visible here. But we can see our two lines are graphed. Our solution of these two lines is going to be the point where they intersect. So our solution is actually this point right there. That is what we will call our solution. Questions so far? If you do, be sure to pause the video, write down that question, and you can ask your teacher later in the hour or possibly tomorrow if you're doing this at night. Now, the intersection of the two lines will be -2, 5. This is called the solution, and it can be written as a point like you see above, or it could also be written as a solution: x equals -2, y equals 5. All right, let's go ahead and take a look. Our objectives today is just to be able to solve systems of equations by graphing. Again, we're also going to take a look at just some really basic substitution problems today as well. So the first couple parts of this lesson are just talking about the different types of solutions you can get when you're graphing. Typically, in most cases, we end up getting an intersection of two lines in one place. When this happens, we get one solution. It is an x and a y, and that solution is just going to be that point where the two lines cross. So wherever the two lines cross, that's what we call our solution. The next type of line you could have would be if lines are parallel to each other. When lines run parallel to each other, they have the same slope. We've talked about that in previous lessons. But we say that there is no solution possible for those types of lines. They never can cross. They're going to continue to run parallel, not ever being able to cross each other's path. The third type of solution we could have is when the lines are actually the same line. These lines are graphed right on top of each other, and we call these lines coinciding lines. Basically, we say there are infinitely many solutions because every point on the line is a solution. They're crossing all the time. So we have infinitely many solutions possible here. All right, let's go ahead and take a look at an example. Why don't you go ahead and graph this line. Now, looking at it, the question's asking, is this a case of parallel lines or coinciding lines? You can graph it to find out. So go ahead, pause the video, graph them, make your conclusion, and then come on back and we'll take a look at what you got for your answer. All right, hopefully you are back. Now, before I even graphed these lines, I noticed that their slopes were the same. And when we have common slopes, what we find is that we have parallel lines. So if I go ahead and graph this though, I would start the first line at -4. And then I'm going to go up 3 and to the right 1. This has a positive slope of 3. Once I graph a few points, I can connect those points with a line, just giving me the ability to see, okay, there's my first line that I've graphed. Next, we're going to graph the second line. The second line, as we see here, has a starting position of +3. I'm going to put a dot there, and then I'm going to go up 3 again, over 1, and plot my point. I could also go down 3 and over 1 just to give myself another point to draw my line through. And now when I go ahead to do this, connecting my points, I'm going to find that, hey, these lines are actually running parallel to each other. Therefore, they can never intersect with each other. This would be an example of a no solution. So again, these lines are parallel to each other. There is no solution possible in this problem. Here's another example for you. In this case, we have two lines that we're graphing. Again, we're asking the same question. Are they parallel or are they coinciding lines? In other words, the same line. As we take a look, I do see that the second equation is not in a form that we are able to graph, so we need to convert it to slope-intercept form. To do that, we divide all parts of the equation by what is attached to the y. In this case, that is that number 3. When we do that, we get this answer that I've written down here right below. So we're going to graph the line y equals -2/3 x plus 5. Now, some of you might be saying, well, hey, isn't that the exact same equation we have for the first line? It is. So at this point, we can actually say these are coinciding lines. But let's go ahead and graph it just for the practice of it. This line we're going to start at 5, so we're going to go up 5 on the y-axis and put our dot. And then we're going to go down 2 and right 3, putting our additional dots there just to give ourselves nice points to draw our line through. Once we get a few points on the graph, we can connect those points with a line, and we've graphed the line. Now again, these equations are exactly the same. So therefore, I have infinitely many solutions in this problem. You guys are doing great so far. Let's take a look at another way to solve problems. So what happens if we want to solve these types of problems algebraically? Since they're both set equal to y, we can actually set them equal to each other and solve for x and y, and then write our answer as a coordinate pair. I'm going to get you started with this just by showing you what that first line would look like. So the first line of this problem is going to look like -x plus 32 equals 3x minus 48. How I got those values is I took this first equation and I replaced it with the y in the second equation. What that allowed me to do was to set them equal to each other, have one variable in my problem, and now I can go ahead and solve. At this point, I'd like you to pause the video and go ahead and try to solve this problem on your own for x. And then if you know how to find the y value, go ahead and do that. All right, welcome back. Hopefully that solving went really well for you. Let's take a look at how I solved the problem first, and then we'll go ahead and move on to the next example. So the first thing I did was I wanted to get the x's on the same side. To do that, I added x to both sides. By doing that, the left side, the x's ended up becoming 0, and on the right side, I had 4x. Next, I wanted to move all of the just numbers to one side, so I added 48 to both sides, giving me 80 equals 4x. To finish solving for x, I divided by 4, which gave me 20. Now, this is great. So far you found one of the two variables. However, I want to remind you there are actually two variables in this problem. To find the second variable, what you need to do is you need to take that solution and you're going to plug it in to either one of the first two equations. It doesn't matter which one you do that to. When I did that, I found that I had y equals negative x plus 32. I used the top equation. I plugged in my 20 for x, and then I went ahead and said negative 20 plus 32 is 12. Now I found both unknowns in my equations that I was given at the start. So my answer could be written as 20 comma 12, x comma y, or x equals 20, y equals 12. All right, let's take a look at the last example we have for you today. Oh, before we do that, sorry, I want to go back and I'm going to show you how to check this on Desmos. If you want to check it on Desmos, open up Desmos. Notice that I typed in both equations into my equation editor spot in Desmos. The red line is the negative slope of x, and the blue line has our positive 3x slope. And then when you click on the intersection point, Desmos actually will tell you that solution for you. So it's a really handy tool and a nice way to check your work. Now let's go ahead and do that last problem that we have here today. So again, solving it algebraically, go ahead. Remember we said that anytime that we have an equation that has the same variable by itself, we can throw that, whatever it equals, in place of the y in the other equation, and then you can move forward to solve. Why don't you go ahead and take a minute, solve this on your own, and when you're done, go ahead and hit play again, and we'll walk you through the solution. All right, welcome back. Let's go ahead and take a look. On this problem, I went ahead again and I subtracted the 5x from both sides. That gave me 2 equals 5x minus 2. Then I added 2 to both sides. Again, I wanted to get the just numbers together on the other side of the equal sign. And finally, I divided by 5, giving me 0.8 for my x value. Just like we saw before, we are not able to do anything else until we take that solution and plug it in. We still have to find our y value. When I went ahead and did this again, I plugged it into the top equation, but it really doesn't matter which equation you plug it into. When I did that math, though, I did get 6 for my y value. So again, my answer can be written as an ordered pair 0.8 comma 6, or x equals 0.8 and y equals 6. Let's go ahead and again just take a peek at Desmos. Again, I graphed them each in their own line in Desmos, and then I clicked on the intersection. Desmos quickly told me the answer. I hope this video helped you understand the different types of solutions that can come from graphing systems of equations, as well as how to do some basic substitution problems. Your assignment for tonight is going to be to do worksheet 3.6a. If you need to pick that up, ask your teacher where it is located. Have a great day.